Let's understand the displacement curve for beats. Here this figure 1 shows the two waves which are having slightly different frequencies propagating in the same direction with say speed v. Here you can see these are the two waves y1 and y2 which started together from extreme position at t equal to 0. And at a particular position you can see as time passes on, the displacement curve of the two waves will split because their frequencies are different, the speed is same, so wavelengths are also different. Here you can see the wavelength of second wave is slightly more than that of first wave. That means frequency of second wave is slightly less than that of first wave. Here initially you can see the two waves started in same phase, and say if these are having each of having amplitude A, then at t equal to 0 this figure 2 is showing at all instant it is showing the displacement curve of the medium particle at which the waves are getting superposed. So in this situation at t equal to 0 as the two are in same phase, the resulting amplitude is 2a. And as time passes, the displacement curves are having more and more offset from each other. And at a position you can see where the wave 2 and wave 1 are exactly in opposite phase. So the resulting displacement of medium particle at this position you can see it is 0. And with time we can say the resulting amplitude is decreasing with time. At this point it is becoming 0. Again after some time the two waves which are in same phase at a particular moment, again the amplitude changes to 2a. And again it is becoming 0 and so on. So this is the way how the medium particle varies its amplitude due to superposition of two waves which are slightly different frequencies. Let's have a look on a realistic animation which is also showing us how the wave propagation takes place. In this continuous running displacement curve you can see there are few points which we have shown which are oscillating at their own positions with the varying amplitude with time. When the two waves superpose at a point in same phase, the amplitude of oscillation becomes maximum, and after some time when the two waves superpose at the same point in opposite phase, at the same point the resulting amplitude of the medium particle becomes minimum. This you can also clearly see. There are few points which are oscillating with the minimum amplitude and few oscillating with maximum amplitude. So at a point when the amplitude is maximum, it produces maximum sound, and when it decreases becoming 0, it produces minimum sounds. With time, a loudness of sound also periodically varies. This phenomena we call beats. Let's discuss an important point about hearing of beats. When we talk about human ears, you must be aware about a fact that human ears can detect beats only up to 12 to 14 Hz. If beat frequency goes beyond this limit, it appears to be a constant sound, or even in case of some aged persons, this capacity decreases up to 8 to 10 Hz only. So we can say for beat frequency more than 12 to 14 Hz, somewhere around 14 Hz in young age, it appears as a continuous sound. We won't be able to detect the waxing and waning of sound. So just keep it in mind. Another fact about beats produced by tuning forks you must also keep in mind, that is beats by tuning forks. We know well that tuning forks oscillate when a tuning fork is hit on a rubber pad. Say we are given with the two tuning forks F1 and F2 which are having frequencies N1 and N2. You can say when these are sounded together, the beat frequency which is produced will be N1 minus N2 if we consider N1 is more than N2. Now in this situation we can say if F1 is loaded with wax, then you must keep in mind whenever we load wax on a tuning fork, its frequency decreases. Loaded as wax, we can say N1 decreases, and if N1 decreases, then beat frequency also decreases. This implies FB will decrease, and if you load F2 with X, N2 will decrease, so beat frequency will obviously increase. Sometime it is given if F1 is filed. When the arms of the tuning forks are filed, these will become thinner, and corresponding to this N1 increases. So if frequency of a tuning fork increases, if it is N1 which is a higher frequency, you can see this implies beat frequency will increase. On the contrary, if in this situation, if F2 is filed, this frequency N2 will increase, then beat frequency will decrease, and it may be possible if N2 goes above N1, then it may further start increasing. So these are some basic facts you should keep in mind if some examples or problems are based on these facts.